So let's demystify the Python runtime environment a bit. Up until now, you've been learning how the code itself works. That is, how the Python interpreter, which is a computational process running on your computer, considers the commands you give it, which are loops, control structures, variables, functions, and how it executes the underlying code on hardware, such as the processor, video card, and memory of your computer, to create some experience for the user. In much of this course, you've been using a web-based simulation environment, Runestone, to create these experiences. With Jupyter, though, we'll be using an environment that is more traditional. A key aspect of this traditional environment are the installation files for Python itself. Let's take a look. I'm going to open up a new terminal. Don't worry if this seems unfamiliar to you. We won't be using the terminal much in this course. I just want to help you explore the Jupyter system a bit. You'll notice that there are a bunch of characters when we open up the terminal. The first set of characters are our username. You can ignore this. It should be the same, Jovian, for all Coursera users. Then there's an @, and the next set of characters are the machine name. Again, the machine name is just auto-generated by the Coursera system and isn't really relevant for our discussion right now. Finally, the rest of the string is the current path, or the location that we're working in. This is useful, and actually if we type the characters L and S in there for list and hit enter, we'll see a list of all files and subfolders in this directory. But I actually want to show you where Python lives on this machine. So we're going to change the directory with the command cd. On the Coursera system, we're using a specific kind of installation for Python called Anaconda. Don't worry too much about that. Let's just change to the site packages directory. This is the real heart of the Python library ecosystem. So I'll go cd, opticonda, lib, python 3.6, and site packages. When we do this, then do a directory listing, we see a whole bunch of things. First, there's a lot of interesting files and directories in here, and these are the third-party packages for Python which are installed on the system. We're going to be dealing with a lot of new packages, but I want you to feel empowered to explore a bit. These packages are just Python files, or sometimes other languages as well, which have been configured to work with the current Python environment. Let's take a look at one that I'm familiar with, called Pillow. Pillow is an imaging library for Python. We can see that it's installed here because there's a Pillow egg file. We can actually look at the source code of the Pillow library by going into the pill directory. So let's cd pill. You'll see that when we do an ls, most of these files are just .py files, Python code itself. We can even take a look at the Python source code behind this library using the more command. Here, let's look at the main Python file in this library called image.py, so more image.py. We can see that there's a bunch of comments at the top, reaching all the way back to 1995. We see a few import statements, then some top-level variables like a logger. We won't talk much about loggers, but they're handy when debugging code. Then we see that there are a few classes which are created, then a math expression, then a try and except block, and so forth. You can feel free to explore this library more by hitting the space bar, or you can exit with more command by hitting Q. So that's a very brief overview of where Python libraries exist on your system. Now, that's not exactly a user-friendly way to interact with the library by reading the source code, but it's a great way to learn how libraries work and how programmers create complex Python solutions. But let's go back into the Jupyter Notebook and explore how to actually use this library.